Welcome YouTubers. Before I get started with today's video, I would first like to thank all my subscribers, especially those who helped my channel to grow by sharing or posting links to my videos, rating thumbs up, or supported my work by allowing ads on my channel, or made a small donation by using the support button on my channel main page or Patreon. Because of your support, I have now reached the 50,000 subscriber mark, and each day between 80 and 100 new people subscribe to my channel. Thank you very much. In this video, I would like to show my viewers, especially those who are new to electronics, two great items that you can buy at a very reasonable cost, which will come in very handy when working on projects or testing faulty components. Keep in mind, there are much higher priced, higher end devices like the two I am about to show you, but for the money, you cannot beat what I'm about to show you. My goal is to help others who enjoy electronics to be able to get what they need to get started for as little as possible. The two items I'm going to show you were shipped to me from banggood.com. I will be placing a link to both items you see here in the video description area. The first thing I'm going to be showing you is this tester on the left. Once I'm done showing you that, I will then show you this ultra compact benchtop power supply. The tester here is a MK328. It is a multi-purpose tester. It has the ability to test the ESR of your capacitors. Smaller capacitors, you will get the ESR reading of the capacitor along with the value of the capacitor, and on larger value capacitors like you see here, you will get not only the capacitance value with the ESR, but the meter will also display V loss or voltage loss across that capacitor. You can also test inductors like the one you see here, as well as diodes. You could connect up an LED. It'll tell you the forward voltage of the LED with the capacitance. You could check relays like this. The meter will test the coil resistance as well as give you a reading on the inductance value of that winding. You can test NPN and PNP transistors. You can also test Mosfets, N and P type, as well as triacs if the gate trigger current is 6 milliamps or less. You can take a potentiometer like this, connect it across the leads, and you will have a readout displaying both sides of the wiper. You could measure fixed resistor values up to 50 megohm. The meter will measure capacitor values between 25 picofarads all the way up to 100,000 microfarads. If you would like to measure values under 25 picos, then what you would do is you would connect in parallel. So for instance, this is a 30. This is a 30 picofarad. So you could either use this little block by removing these wires and plugging it inside the unit. Then you could just lock and unlock very easily, put your components in. But you would take that component, which is below 25 picos, and you would connect it in parallel with one of a known value. So if I know that this value here is 30, then what I could do is I could take a 2 pico, parallel it up with this one, and get a reading, and it will be 32. You would just subtract the 30 from the 32, and then you would know you have 2 picos. So if you did have to test under 25 picos, which is really not that often, but if you did, at least you can do so using this meter. When you test inductors, you can test between 10 microhenry and 20 henry. The unit operates on a 9-volt battery. Now, if you were going to purchase just an ESR meter, that alone can get very pricey. So when you see a unit like this that has the ability to test so many different things, and it only retails for around $32, this is something I would definitely recommend that you purchase. Let me give you a little demonstration here. Let's start off with testing a capacitor. Now, it does not make a difference which one of these you connect to. I can connect the capacitor between the yellow and the green, the red and the yellow, or I can connect it between the red and the green. Just connect 2 up make sure the capacitor has been discharged before connecting it to the meter. Let me push the test button. Alright, this capacitor has written on it low ESR. I don't know if you can see that. Alright. Your reading for ESR is 0.05 ohms. The value is 3,000, almost 3,400 microfarad. And this one is rated at 3,300. And it tells you the voltage loss based on that resistance is 2.5%. Now, as you saw, once the reading is taken, if you don't press the test button again to perform another test, the display will go off, and the reason for that is to extend the battery life. Now let's take a look at something else here. Let's try a different one right here. Alright? So I pulled this capacitor out of an old computer. Let me put that together there. Let's press test again. 5,139 nanofarad, and look at that ESR value, 0.15 k ohm, 150 ohms. This is definitely not a good capacitor. Let's try a smaller one. That's 0.43 ohms, 96.99 microfarad. That's a 100. And the voltage loss is 1.3% at that resistance. And it's also showing you between 1 and 3, right here and right here, is where the capacitor is connected. Let's take a look at a different component. Here's a very small one. This is a 33, it looks like. It's very small. Picofarad. Connect that up. Alright, 30 picos, voltage loss 0. And as I said earlier, if you wanted to test lower, you would take this off like this, remove all these. Very easy to do. Take this right here. Slide that in. Once that's in position, you have test pads for number 1 here on top, number 2 is the bottom left, and 3 is the bottom right. If you look at the very bottom, right here it says 1, the first row is number 1, second row is number 2, third row is number 3. You could take these and you would go like between 1 and 2. Alright, you can put that in there, lock that down, push test. You should have the reading of 30 again. 29, close enough. And what you would do is you would take the next capacitor, say it was only 3 picos, because you can't measure 3 picos because it's under the 25 that the meter is capable of measuring. You would take the 3 pico and you would insert it into the same number 1 and number 2 slot, which you can actually do right here. See 1 and 2? So the first one there and the second, you would place the other one. They would be in parallel, and you should see a reading of around 33. You would subtract the value that you know, which was 30, and it would leave 3 behind. You would know the value of that capacitor is 3 picos. Let's pull this back out. Put this back together here. This is gold plated. Let's take a look at a potentiometer. I'm going to connect one side there, green there, and let's connect that there. With that connected up, press the test button. You can see right over here between pin 1 and 3, alright, the red and the yellow, you have 53.56 k ohm, and between pin 3 and 2, you have 3760. So it's around 56K across the entire potentiometer. Let's try this inductor right here. Okay, the resistance of that winding inside this inductor is 0.1 ohm, and the inductance is 0.02 millihenry. Over here you can see the symbol for an inductor, and it was between 1 and 2, which is what it is right here. Let's try an LED. Alright, you're going to power that up. It shows the anode and the cathode. The anode on 1, cathode on 3, the forward voltage of around 1.77, and that's the capacitance right here, as well as the reverse current at the top right. Let's get rid of this. Let's try a diode. And you can see the anode cathode there, the forward voltage, the capacitance, as well as the reverse current at the top right. Like that. Let's try this little relay here. Okay, let's turn it on. There is roughly a 700 ohm relay coil inside of here, and the inductance value of that coil is 436 millihenry, shown between 1 and 3. The red and the yellow, red and the yellow. Let's try this right here. Let's see what this is. It makes no difference on transistors, Mosfets, triacs, where you position the wire. It will automatically detect. You can see right here it's an N-channel Mosfet. If it was a P, you'd see a P here. 1, 2, 3. 1 is the gate right there. 2 is the drain, top right. And 3 is the source, bottom right. And it also shows the protective diode inside the Mosfet. And this is the threshold voltage. Over here is the forward voltage, which is actually 0.59 volts. And the capacitance is 1.08 nanofarad. Try this. Okay, we have an NPN transistor, and it's identifying which is the base, the collector, the emitter. You have the forward voltage around 0.62. The 40 with the B here is actually the HFE. And the other two readings refer to current readings. Those are at 0. Let's try this. Okay, let's see what that one is. You may notice the battery voltage is dropping a little here. I've been doing a lot of testing to make this video, and I'm only using a heavy-duty battery inside the meter. It does draw around 20 milliamps for the testing and to power the backlight on the display, so be sure to use a 9-volt alkaline or lithium battery. Alright, this is showing a triac. It's showing the terminal 1, main terminal 1, main terminal 2, which is 2, and the gate is at 3. You have the forward voltage of 0.81, and here's your little diagram showing the triac. Let's press the button on that one. And you can see it's a PNP. It identifies the base collector emitter, 0.609 volts, or 609 millivolts. And it gives you the HFE here, which is around 150. Let's try the last one here. Lay that down. Push test again. Okay, we got a P-channel Mosfet. You have the drain, gate, and source identified with pins 1, 2, and 3 over there. You can see the protective diode in position on the right. Forward voltage around 0.84. Capacitance 157. And you also have VT, which is threshold voltage. You can see that on the right. A very useful tester indeed. It's the back. You have two brass inserts molded into the plastic. When you unscrew this, you would see those with the 9-volt battery. Okay, let's get on to the power supply. This benchtop power supply is very nice because it's very small, it's very compact, and you have the ability to go up to 32 volts and up to a 5 amp output. Let's take a look at the entire unit. Move that out of the way. Alright, you have a 115 volt or a 230 volt selector. The output is on the rear. You could use the plug type like you see here, or you could unscrew, slide the blade connector over, and tighten it back down. Now I love everything about this power supply, but it would have been a little nicer if they did have this right here installed somewhere on the front, but clearly there wasn't room to put it in the front, so it's definitely not a problem having it in the back since we have this long cord right here that we can use. When you go to adjust the voltage, you put the switch up, and that allows you to adjust the voltage. You slide it down, and that allows you to adjust the current output. Once you have everything the way you want it, you can push lock, and it will hold those settings. Let me power this up and show you how well it works. Let's turn it on from the main switch in the back. Power is still off. Let me push the membrane switch here. And it's going to go to my previous setting, which is 12.3. If you want to adjust the voltage, it's very simple. Make sure the voltage switch is up. You could rotate the dial. Alright? If I rotate the dial, it's going to adjust where it's currently set at, in that spot. If I push it, now it moved there. Again. In that position. So if I want to go 30 volts, I got 32. Let me lower that to 0. Alright, so I'm set at 30 volts right now. And 100 milliamps as you saw. Let me go to the current setting. That's 100 milliamps. 99, 98. Let me push over to there. Alright, you see the decimal come in now. Now it's 1 amp. 2 amps. Up to 5.1 is the max. I could do that. And I could lock. Now say I would like to charge a lithium-ion 18650 cell. What I could do is I could put the voltage switch up, unlock, which it did. Let me move over to there. Let's put that to 0. Let's put that at 4. And let's put that to 2, 4.2 volts max. And I could do the current. I'm going to move it over to the next spot. And I can set it at 300 milliamps and press lock. Now when I connect this right here to the battery, as long as I monitor the temperature, I'll have 4.2 volts at 300 milliamps going into that 18650 battery. The unit is very easy to use. This benchtop power supply, considering the price, which retails for around $58, it is definitely a great deal. You're getting the ability to go up to 32 volts and up to 5 amps. The unit is controlled by a microprocessor. It is very close to 90% efficiency. The unit has this nice aluminum housing. The ripple is very low. It is less than or equal to 30 millivolts peak to peak. And right here is a closer look at the specification chart. The unit I have is the one in the center, CPS 3205. Look that over quickly. What I would like to do now is test the current output on this unit to see if I can hold that voltage up to 5 amps. Maybe it'll be a little less than 5 amps, or maybe it'll be a little higher. I'm going to be using this 18 volt cordless drill. That's your current and the voltage. Keep an eye on the current and the voltage to make sure it stays steady once it's running. The initial surge from the motor will cause this to drop slightly, but it will go right back up quick. I'm going to take this rag and add a load to the drill to increase the current. As you just saw, the 20 volt output was very stable up to around 4.5 amps. Once I went higher than 4.5 amps, we started to lose our 20 volts, and when this was 5 amps, this was down to around 18.25 volts. So they were a little bit on the high end with the rating. It should have been 0 to 4.5 amps, but still a great deal for the money. If you enjoyed this video, please rate it a thumbs up, subscribe, and post links to this video on other websites and blogs. Also be sure to check out my video playlists as well. Thank you very much for watching.